It's really great to be back here with the Dutch team and going through another webinar. I've done a few webinars for you guys in the past, and this is really going to be a kind of a little bit of a dig down into one area. A lot of times when I'm doing webinars, I kind of try to cover a huge swath of information on the HPA-axis and stress and all kinds of things. And today I just want to kind of create sort of a foundation, what I call the fundamentals for clinicians. So if you're not a clinician, this will be a little bonus for you. On the importance of measuring diurnal cortisol, the cortisol awakening response, and beyond. And I know that if you've been watching any of the seminars and webinars that Mark and his team have done, you've probably heard a lot about the cortisol awakening response. And hopefully what I'm going to try to do is give you a little bit more of a bigger sense of why this is so important as clinicians and as a research tool more broadly. And it's partly because you guys are doing things that not everyone is doing. So I just want to start where I always talk about my stressful mission. I guess advancing my slides right there was one of my stressful missions. But I've been talking about this for a while to realign the functional medicine community, the integrative medicine community, whatever term you want to use that encompasses what you do, to the current research on HPA-axis and stress dysfunction. And if you know anything about my background, and I'll mention just briefly a little bit today, that this has not always been the case, and it's still not the case in some areas. I really have been spending a lot of time trying to expand the view of the HPA-axis beyond the stress response. So I won't get into that, but well, actually, we will talk a little bit about today on the circadian control of biology, to create a common nomenclature around stress and HPA-axis function that's useful and accurate for the healthcare and scientific community. And I'm sure I know Mark and others have kind of hopefully beat in your head the idea that adrenal fatigue, pregnenolone steal, and some of these things. I know we did a podcast about that as well. You should watch that, and you can kind of get a sort of a history of where that came from and us dealing with those terms, which are still around. One of the things that I spent quite a bit of time on, ironically, was to encourage more uniformity in laboratory testing around HPA-axis function. So the units that are used, the nomenclature used, the collection timing, how it's collected, the instructions for collection, and to encourage test menu options that mirror published literature more closely. And I got to say, the Precision team and Mark have really taken that to heart, as others have. But I think they've done a really, really good job of saying, yes, you're right. We need to start including some of these things in our tests and make them available. And you guys if you're using the Dutch test, you know that he's done that. To promote more research related to testing and HPA-axis interventions, and then to help clinicians incorporate HPA-axis therapies to prevent and treat stress-related chronic dysfunction. So that's really kind of what I've been doing since, for the last almost 15 years, I guess, or longer in this particular area. But I want to talk to you today about clinicians as researchers. And obviously, every time you have a patient in front of you, you're digging into something, you're doing these tests, you're trying to discover something about the patient. It's a research project, N of 1, maybe N of 1 plus, depending on the sequence you're having, sort of the clinical sequence of different patients. So if you are investigating the underlying root causes of complex chronic disease in your patients using specialty tests like this, these are specialty tests, you really need to know more than just how to interpret the results. And so that's hopefully what we're going to dig into today. So I really think you should understand the fundamental research that undergirds the test which has been performed. What is it really measuring, and what does it mean? And thinking about other implications of the test results beyond the immediate and direct interpretation. And this was certainly true of when just the 4-point cortisol tests were very simplistically used throughout the functional medicine community for decades. To be keenly aware that how and when the samples were collected impact interpretation of the findings. So this is really important. I think Mark and the team there has done a really good job of helping patients do that, but this is really, really critical. And we'll talk about not just the moment that the test or the sample is taken, but even the day, the time of year, the time of the month, all of these things could have an effect on that. And then really to be able to explain to peers and critics the the clinical benefits for specialty testing that's not common for diagnosing diseases. Mark and I were just recently talking about people on their blogs, they're critiquing Dutch testing and other sort of testing, and talking to endocrinologists, and an endocrinologist saying to them, well, I don't know why you would want to take a test like that, because I really can't diagnose a disease with it. And so therefore I wouldn't use these kind of tests. And that's obviously short-sighted, but if you understand you really need to understand how would you respond to someone who would say something like that. Do you really understand the depth of the research behind what undergirds this test? So I'll start here, and I think I might have had these slides the last time I was with a webinar here with Dutch, but the popular language for stress is driving a lot of this, and unfortunately it's driving it from the clinician side and the patient side. So you've all seen books like this, and I don't need to, I just kind of pulled these out, and you can see there's a little bit of a theme going on here. And so the popular language around stress is all about adrenals, all about adrenal fatigue, and that's a language that has been adopted and co-opted and used in so many different ways. In fact, there's this great example of how this gets confusing. So here's a paper, if you're not familiar with this, in 2016, somebody wrote a paper called "Adrenal Fatigue Does Not Exist: A Systematic Review." And I put it here, yes, this is as ridiculous as you would imagine, but when you have published literature like this, it does bolster this idea that a clinician can go online, they can type this in to PubMed, they can find this out, and they can say, see here, your ideas are totally bogus, and you can see the conclusion. It says, this systematic review proves that there is no substantiation that adrenal fatigue is an actual medical condition. Of course it's not. Therefore, adrenal fatigue is still a myth. And it's like, somehow that was some wonderful conclusion that they had. But these are the kinds of things that kind of embolden people who would say, well, all of the testing that's being done, all these salivary, the cortisol testing that you guys are doing, it's all part of this adrenal fatigue idea, and it's all been disproven. Okay, and I think this is why it's really important for you to understand some of that. So when did stress become all about adrenals? And so obviously the adrenal gland, it's the HPA-axis. So the A is still important to the HPA-axis, but when did we get this sort of just merging of language? Well, a lot of it has to do with the fact that we think adrenals because we test cortisol, and cortisol is being produced by the adrenal gland. So we think in some ways that if we're measuring cortisol, we're simply measuring adrenal function or the adrenals. And if cortisol goes up, if cortisol goes down, then that's telling us what the adrenals are doing. And of course, we won't get into the phenomena. We talk about it on several different podcasts, and I know Mark has talked about it on some of his webinars about why adrenal fatigue is not tied into adrenal function for the most part. So anyway, this is sort of the logic that we have. So you've all seen sort of diagrams of the HPA axis like this. But what are we trying to measure when we're looking into this pathway? So what we'd like to measure is what is the relationship between a stressor and its metabolic effect. So obviously that's what we're trying to figure out. When a patient is in front of us, we want to know the stressors in their life, whatever they happen to be, whether they're internal, whether they're external, whether they're perceived, whether they're real, whatever. How is that changing their metabolism, their risk for disease, what's going on in the rest of their body, signs and symptoms that are actually meaningful to them, perhaps even to their risk factors for disease patterns. So obviously we're trying to do that. We also would like to know, if we can, the resiliency of a person's stress response system to withstand additional stressors. So what is their, if we want to use this term, stress reserve capacity? Where are they in the process? Maybe they're not having metabolic effects, or maybe they're having some metabolic effects, but how far along this reserve capacity depletion are they? And are they at the very end where they're going to have a really difficult time, or do they have a lot of resiliency left in the HPA axis? We'd also like to know how acute and chronic stressors have affected the circadian nature of the HPA axis. Now, obviously, this talk here today is about diurnal rhythm, so this is something they're going to talk about. But one of the reasons that we're going to see that we want to know about the circadian biology of the cortisol secretion is because it has a high influence on their circadian metabolism throughout all tissues. And then also, we'd like to know what are the most likely therapies or changes that can increase a person's ability to improve their HPA axis or the HPA axis mediated functions. So that's obviously, so all of these kinds of things we'd like to get, but we can measure some of the stressors, we can ask them, we can measure some other things. Very difficult to get a handle on CRH. ACTH can be measured in the serum, but obviously to know what's going on a regular basis, that would require constant blood draws. So as it turns out, cortisol has become the best surrogate marker for this whole pathway. Now, I say it's the best surrogate marker we have. It's not perfect, and it does oftentimes give us some anomalies, but yet, nonetheless, it really does give us the best window into what's going on, if you understand the nuances of a number of different things that we're going to talk about, and as you've learned over the years. So it's not just about measuring cortisol only. It's measuring cortisol with some information and in a nuanced way. So most of you hopefully know that cortisol is a surrogate, a pretty good surrogate actually, of total, a total cortisol is a very good surrogate for ACTH. So if you take serum cortisol and serum ACTH, they will mirror each other within a few minutes. Obviously, ACTH would appear in the bloodstream slightly ahead of the cortisol by a few minutes because there's a slight delay. Cortisol has to be made, but it's made very quickly. And it follows along very closely. So not surprising. So this is just just one of many you can find images where you can follow these along. And these are actually serum or plasma levels of ACTH and cortisol every 15 minutes. Note, however, and this is something that we're not going to spend too much time on, but it's something you should be aware of, is that both ACTH and cortisol have an ultradian rhythm, not just a circadian rhythm that you can see here, highest in the morning, which is actually, on this case, on the right-hand side, because that black bar is when the patient is sleeping or the person is sleeping. So you can see the spike in the morning on the right-hand side. But you'll see about every 60 to 90 minutes, you'll see a pulse that typically goes up in both the ACTH and cortisol. And this is what's called an ultradian rhythm. And there's actually even smaller pulses inside of that. And while we won't spend time on this, the last webinar I did for the Dutch team, we talked about the ultradian rhythm as a way for the body to distinguish between a circadian rhythm and a stress-induced rhythm that's out of sync with the biology. So let me just briefly talk about the nomenclature of adrenal insufficiency, because this plays into a little bit of some biology that we need to talk about, and also some nomenclature which is actually wrong or at least misleading in the broader medical community. And of course, on the left-hand side, primary adrenal insufficiency is where we have typically an autoimmune destruction, essentially, of the cells in the adrenal gland that produce cortisol. So you can, this person produces ACTH, but they produce very little or no adrenal steroids, cortisol in this case. And so we have a very low cortisol levels. So we have Addison's or Addisonian condition, but you have high levels of ACTH. And so one way you can obviously diagnose this is very low cortisol, high ACTH, or giving somebody ACTH doesn't elicit a cortisol spike. Secondary and tertiary adrenal insufficiency, you'll notice, are not adrenal insufficiencies. They are cortisol deficient conditions, but they are not adrenal conditions. They're either secondary adrenal insufficiency is typically defined as when the pituitary does not produce enough ACTH, when it's given a signal from CRH, doesn't produce enough ACTH, and therefore there's not enough signal to produce cortisol, and you get a low cortisol output. Tertiary adrenal insufficiency is where we have, usually in the hypothalamus, something is downregulating the production of CRH, which then reduces ACTH and reduces cortisol production. So we're gonna talk a little bit about this, because you'll notice these red dots, and you guys know there's feedback inhibition of steroid cortisol production, that feedback and creates an inhibition in both the hypothalamus and the pituitary. But we could argue, somebody could argue and say that stress, chronic stress, which reduces CRH and ACTH, could be deemed a secondary or tertiary adrenal insufficiency. I don't like that terminology because it's not an adrenal issue. So these really are not adrenal issues either. So I wish they would probably call these some sort of, HPA-axis downregulation is really what they are. And we're going to talk about stress, chronic stress, as an HPA-axis downregulator as well. We should note that tertiary adrenal insufficiency can be driven by oral or other corticosteroid therapy. The more corticosteroids that you're giving a patient over a long period of time, or high acute amounts over a short period of time, can drive a downregulation and drive or increase the risk for tertiary adrenal insufficiency, at least the way that nomenclature is used traditionally. So the reason I mention that is because this paper came out quite a few years ago, like 15, 16 years ago, 2005, and it really, within the community of people that were looking at this, we really kind of rallied around this. This was work done by the group in Trier, Germany, Hellhammers and their group, and they published this, what they call the new view on hypocortisolism, or a new view on low cortisolism. And essentially what they talked about was this adaptation to chronic stress could be viewed as a secondary or tertiary adrenal insufficiency. Now, they didn't use that language, but what they basically said was, they said, based on their results, they proposed that hypocortisolism is a protective response dampening chronic HPA-axis activity, and thereby reducing the damaging effects of glucocorticoid response to daily hassles at the expense of symptoms such as high stress sensitivity, pain, and fatigue. So what they're basically saying is, after a while of having elevated cortisol levels, the brain downregulates itself to basically yield a low cortisol environment to protect the brain and other sensitive tissue to this elevated level of cortisol. So we're gonna see that this is referred to sometimes as HPA-axis burnout, where you have a burnout. Now, that burnout is not in the adrenal gland, it's in the brain. So the brain is slowing down the production of CRH and ACTH. So the paper that I use that I think is interesting now, and this is gonna, again, if hopefully you can see this on the screen, you're not driving in your car or something. And this is a paper that came out, and they were asking the question, what happens when we put someone who has burnout versus a control individual in a psychosocial stressor? So I don't have time to talk about the Trier social stress test, but essentially in a short description, it's basically walking somebody into a room with a table with 3 people behind it, and these people, the person that's in there thinks they're in there for some reason, maybe a job interview or something like that, and the people start asking them very difficult questions, including mental arithmetic, very difficult mental arithmetic, and as soon as they get it wrong, they tell them, no, that's wrong, start over. And it's very stressful on these people. It's very predicted to be stressful. And you can see on the left-hand side here, the very top is basically ACTH. So the blue bar here is when they go through the test. It's about a 20-minute test. And you can see there, the ACTH shoots up. There's a serum level of ACTH. And you can see here, this is their serum cortisol, goes up just along with the ACTH. Very much goes up, and then you can see this curve, and it slowly comes back down. Below here, you can see salivary cortisol. And the salivary cortisol, you'll see there's a contradiction here. These individuals that are patients who have high amounts of burnout, or I should say have burnout, have elevated serum elevated serum cortisol, but a suppressed salivary cortisol. And And so there's what accounts for this? Why would they have a blunted response in the saliva and yet an exaggerated response in the serum? So what they started asking the question, and the determination of what burnout was kind of vague. So what they did is they took their scale of people on burnout and they cut it in half, and they said anybody that's on the high end of what we call burnout, we will look at their numbers separate from the people who are on the low end of burnout. And it turns out they saw a difference between, and what it turns out, the people that had low burnout were not really burned out. They were still under high chronic stress. The people who were at high burnout were truly in what we would call burnout. And how do we determine the difference? Well, they basically took these individuals and they separated them. And now you can see the difference. The people that were what they call low burnout, you can see this, the ACTH levels were highly differential. So the people that were low burnout, we could call these high acute stress still, they had a high level of ACTH and a very high level of serum cortisol, which is what you'd expect. And the people with high burnout, these are people that let's call it true burnout, had a suppressed ACTH response and a lower amount of total cortisol. But when you go down to the saliva, there is some difference. The subjects with low burnout, meaning high stress, have elevated total cortisol that mirrors the ACTH, but their salivary levels don't. And while we don't have time to get into this, because this might be something that I'm going to do in the future, what they're predicting and what seems to be happening is one of the initial adaptation that occurs is an increase in corticosteroid binding globulin. So as it turns out, maybe one of the transitions from going from acute stress, where you have high levels of cortisol, one of the first protective ways the body deals with that is not by suppressing ACTH yet, but by actually increasing the amount of binding globulin to reduce the free cortisol so that you reduce the cortisol response in the body. So it's maybe the first protective way to do that. Eventually, we can see with these high burnout individuals, eventually these people are going through a HPA-axis suppression of their ACTH. So again, we can maybe, again, this is sort of the wrong way to use the nomenclature, but a stress-induced adrenal insufficiency or a stress-induced HPA-axis downregulation, which is driving the hypocortisolism. So the reason I show you this paper is because there's lots of papers like this that have been published over the years where people are trying to understand the progression of chronic stressors and how the HPA-axis is adapting. And you can see a lot of times when we lump all these people, sometimes you'll see in the literature that burnout doesn't do anything. And it's the problem with that is we're using very vague terms, even in clinical literature and research, we're using some vague terms and we're pooling all kinds of people together. And in here, you can see if they had they just stopped at the total on the left-hand side, we wouldn't have learned a lot. But because they then stratified them between high and low burnout, they discovered that some of these people were in an HPA-axis, what some people might refer to as stage 3, where their cortisol is being suppressed, and some of these people are still in stage 1 or stage 2, going through that adaptation stage where cortisol binding globulin may be acting as the adaptive component. So my last seminar for Dutch, I spent a lot of time talking about circadian function and cortisol. So I'm not going to talk about this in detail, except to just remind you that glucocorticoids, cortisol, are one of the chief ways that the suprachiasmatic nucleus, the clock in the brain that signals the hypothalamus to know when the 24-hour cycle is being resynchronized, signals the peripheral clocks in all your tissues with cortisol. So cortisol is one of the main signaling hormones to tell the whole rest of the body what time it is, at least what time it is according to the brain. And so this is obviously an important thing. And we actually spent some time talking about the fact that glucocorticoid receptors, which are the transcription factors within the cell that bind to cortisol, they actually have direct effects and are directly affected by clock gene transcription. So we're not going to get into that detail, but that whole sphere of influence is something that as clinicians you should be aware of, that that what we call the stress response system is also the circadian controlling system of the body. So for those of you who are clinicians and are doing this kind of work on a regular basis, this is I think a must-read review article that talks about how or the clinical significance of the 24-hour rhythm of circadian glucocorticoids. So it really talks about how the diurnal rhythm of cortisol is affected by or diagnostic of certain common conditions or lifestyle decisions. So different things that occur in the body that change this rhythm. It's free and available online. You can download it. You don't have to have a password or anything to get in there. But it's something that you should read because it shows you how influential and how important it is to know what's going on a circadian rhythm for cortisol production. Here's another paper. This was George Chrousos and his team out of I think Athens, Greece. And I'm just going to show you a couple different things that you should be aware of. Obviously, they've done a lot of work on people who have shift work. You know, they work on different times of the day, and you can see pretty dramatically. Obviously, they have a different serum cortisol and salivary cortisol level. Stress obviously does a shift on that. At the bottom, you will see something very interesting. Most everybody here probably knows that cortisol is highest in the morning. But did you know that glucocorticoid receptor acetylation is also highest in the morning, which suppresses the glucocorticoid sensitivity in target tissue? So we will talk about this in a future webinar, but there are many, many ways for each cell and each tissue to modulate its own sensitivity and its own reactivity to the cortisol that you're producing. I just mentioned corticosteroid binding globulin. Here we're talking about glucocorticoid receptor acetylation, and there's a whole bunch more. But you can see that this is being modulated also on a circadian rhythm. In the upper right-hand corner is something that I just want you to put a pin in as a way to think about this. Another way to look at what's going on with the HPA-axis, and this is a dexamethasone suppression test. And you can see in this case, this is just showing normal subjects versus people with Cushing's disease. And you can see that when you give somebody dexamethasone in the evening, it's an overnight test. You give the dexamethasone at night, usually 1 or 2 milligrams. And the next morning, a normal person, because that's still suppressing their HPA-axis, they don't produce much cortisol. But somebody with Cushing's is able to break through that and produce more cortisol in the morning, even given dexamethasone. So this has actually been used also to look at acute stress versus burnout. People with burnout have almost a flat cortisol in the morning. You give dexamethasone. People that have acute stress and high amounts of ACTH can break through that. So there's other things that you should be aware of in the research community that actually are available to some clinicians if you're willing to look into the literature. This is sort of the last major recommendation I'll make here. This is a paper that you can also find, I believe, online for free. It's just called the Human Stress Response, review just from a couple of years ago. And it also really gives you a sense of some of the research that's been done. And they also focus quite a bit on the circadian biology of the HPA-axis and the influence of cortisol or glucocorticoids, because they talk about both humans and rodents, and how it affects all these other tissues through the peripheral clocks. But I want to point out one of the things that they mentioned in their conclusion, and that is this. I'll just read it. If we are to understand the growing epidemic of stress-related human disease, we need to go back to first principles and understand not only the mechanisms underlying the regulation of our pattern of physiological activity and hormone secretion, particularly over the important and notorious difficult nadir or low period during sleep, but also why they are important for the maintenance of health. And I think this sentence is really important. If we are going to aspire to an objective of optimal personalized medicine, we need to devise methods not only to measure dynamic basal patterns of hormone metabolism and immune function over the whole day, but also novel therapeutic interventions to counteract the causes of environmental related or stress related illness. So this is this is your counter argument for anybody that says, why are you measuring this? Why are you measuring 4 times a day or 5 or 6 times a day of the cortisol? Makes no sense. All you got to do is measure it once. Basically, that's like 25-year-old thinking. This paper now, says very clearly that if we are going to do this right, we need to measure this throughout the day, the whole day, and we need to devise mechanisms for understanding how those measures can be counteracted or influenced by environment or stress-related illness. So, I mean, this is really, I think, something that, again, you should read this paper, because, again, it really sets the ground, sets the foundation for understanding this. So let's go back. If you've been around, you know that for many of you, you were doing what I used to call standard 4-point salivary test. It's a good start, but opportunities to expand. So when I started writing about this in the early teens, actually the first thing I wrote on this was like 1999. We started, obviously there was many labs that were doing a 4-point salivary cortisol test, but as it turns out, many of them were doing the first morning cortisol test anywhere from 6 a.m. to 9 a.m. And the instructions that were given were very vague. Just take it in the morning sometime. Sometimes it was more specific, but sometimes it was very vague. So if you woke up at 6 a.m. and you didn't take it till 8:30, you technically were doing it correctly. You were spitting in tubes, and many people found that was difficult. I know Mark and his team have gone with these salivettes, which is really what's used in most of the clinical literature. They use these salivettes, which are a much easier way to collect the cortisol. It's very good for collecting cortisol, maybe not so good for everything else, but it's really good for cortisol. So this was the standard in sort of the lab. But as it turns out, during those intervening 20, 30 years that the labs were doing this, the research was moving on and finding other things. So if you just look at what would happen if you did a 4-point salivary cortisol test and you tried to capture what was going on during the day, you'd get something like this. And I don't have time to get into why there's a little blip during lunchtime and sometimes even dinner, but as it turns out, carbohydrates will actually stimulate cortisol for a brief moment, and that's why you typically get these little bumps during lunchtime. Anyway, but what happens was they were missing this very early difference, and so you would just get one time point somewhere, hopefully around the peak in the morning. But like I said, if you're not doing it in a very diligent way to capture that peak, you're going to miss that. So I often show this is what it would look like if you actually captured what is known as the cortisol awakening response. That difference between the time you awaken and the time, typically 30 to 40 minutes, 45 minutes later, where it peaks and then it comes back down. So that's what we call the cortisol awakening response. And the area under the curve, or what you're measuring, you can see it can be dynamically different if you do that. So I always remind people that, obviously this data only represents the day of sampling. So it's really important for you to understand that. And so this is what I think the typical reference ranges that Mark would use, or that Dutch Labs uses for this. And obviously it's not to scale because they exaggerate sort of the awakening response. But nonetheless, you can see here by taking 5 points instead of 4 points, you can capture the time 0. And the other benefit you have is if you are capturing time 0 and you know that the next collection is plus 30, then you're almost guaranteed to get that peak because you're not just estimating when that first one is, or in this case the second one, you're actually triggering it off of the awakening itself. So if you're not as familiar with the cortisol awakening response, you can find a lot of stuff in the literature. It basically, and of course, other webinars that Precision Analytica has done. So go on and listen to those. But essentially, it's the rise in cortisol, and obviously we would see it in the serum if we were able to measure it every 15 minutes in the serum. But it can be collected just as easy in the saliva, and that's why we do that. It's the rise from the time of awakening to that peak, And typically it's measured until typically an hour. So in the clinical literature, it would probably go all the way to 60 minutes, and then you'd look at area under the curve and these kind of things. It essentially is the combination of the circadian increase in ACTH followed by the surge in ACTH that occurs when light hits the retina and triggers the suprachiasmatic nucleus. And that triggers more ACTH, but it also triggers a direct effect on the adrenal cortex, which then changes its sensitivity to ACTH, so you get a spike. So you, even though you have ACTH there at the adrenal cortex, you see this direct innervation from the suprachiasmatic nucleus, and you get this burst of response to that ACTH, and that coupled together gives you this burst. And again, when I first kind of, I should say I stumbled across this, I was like, how come nobody in our industry was talking about this? And this is a paper, from over 20 years ago. Actually, no, this is probably a paper from maybe 13 years ago, I think it is. That basically just looks at the cortisol awakening response and the psychosocial factors, a systematic review and meta-analysis. And this basically showed, you can just see the number of clinical trials that were using the cortisol awakening response, showing that people with elevated job stress and elevated generalized stress typically had an elevated cortisol awakening response. People that had fatigue and burnout typically had a lower cortisol awakening response. Sometimes we call it a blunted response. And then people with PTSD also had a blunted response. So this was all over the literature, and nobody really was doing it, or it certainly wasn't available. Mark has done a lot of work, and Dutch Lab has done a lot of work with dried urine samples. And if you followed any of the webinars that talk about this, you know that also obviously has a circadian rhythm as well. And artificially, it looks sort of like it's collecting the same information. The difference is obviously the urine is collecting, it's collecting cortisol in urine from the last time it was voided. So the first morning cortisol is really all the collection from the night before, and the next one you take is sort of the collection. So the car is in there, it's tucked in there, but it can't be really teased out, because what you want to see is the true difference of what's being measured at time zero, and you want to measure that light response that you're getting. So even though it's sort of artificially there, you can't really measure the cortisol awakening response. Now, Mark has done a yeoman's job of publishing the data that they're getting, and I commend them for what they're doing on their publications. And I think they're going to do more. And so I think we're going to tease out more and more of the nuances for how we can use urinary free cortisol, and of course all the metabolites that he's measuring. He's learning more and more about how to use them in interpreting patients. So, but if you dive into the research components of diurnal cortisol in the literature, you'll notice that there's all kinds of things being measured. So the cortisol awakening response is one, but in the literature, people are measuring the slope from the peak down to the early trough that we typically see 2 hours later. The overall slope from awakening to bedtime, that's also being measured. And then even the late decline slope. So all of the slopes of these curves, including the area under the curve, sometimes the area, the dynamic area, or the one that goes all the way to the floor, all of these area under the curves are being used in the clinical literature for various things. And so people are trying to discover, can we use all of these or some of these or the ratios of some of these to understand what is going on in the dynamic aspect of the HPA-axis. So as you can imagine, after so many different studies, people don't always do them the same. So this is, if you look at the names of these researchers, these are like all of the main researchers doing cortisol awakening response and stress-related research around the world. They came together and they have this review article about from 2016 looking at the guidelines, and they obviously realized that cortisol awakening response is a natural phenomenon, but it's also a biomarker. So as a biomarker, they want to make sure it's measured the same way each time. And as it turns out, that requires everybody kind of agreeing on what the best way to do that is. So anyway, this is another great article to give you the sense of the nuance. And they, of course, discovered that just missing when the timing of that is taken, especially in the literature, can make a big difference. So if you delay it by 8 minutes, you actually increase the area under the curve, the way it's measured in the first 45 minutes. But if you delay it by 20 minutes, you can see the area under the curve shrinks down tremendously. So, and of course, if you delay it by 40 minutes, then you're on the opposite side of the curve altogether. And so what does this mean? Well, for most of you, it doesn't necessarily mean anything, but it does show that if you are only measuring a single time point, like doing the 4-point test that is typically done, you could completely miss this peak altogether. And for those of you who realize that typically labs give you what's called the cortisol sum, where they sum up all 4 of the measurements for the day, that morning level basically is half or more of the total. So if you don't find that peak in that 1 point, you are going to miss that. So if you happen to be doing just cortisol awakening responses and things like that, and you're trying to really follow this in your patients, this is something you'd want to know. So what else do you want to know? Well, what day did your patient take their cortisol test? Here is a study looking at perceived work overload in individuals, and what they basically discovered was a couple different things. One, in some of the literature, it suggests that women peak in their cortisol somewhere between 30 and 45, sometimes closer to 45. Men are closer to 30, so that's why the 30 is good for both, but sometimes you see a little delay in women, and that actually might be related to the monthly cycle. But look at the bottom. The difference between those taken on a weekday versus those on a weekend. So there's a cortisol awakening response is much higher during their normal weekday. And these are people obviously that are working, not retired individuals. And you can see a blunted or a lower cortisol awakening response during the weekend. So we typically tell people take this during a normal work day with normal anticipatory stress for that day. But you can see when you have a lower anticipation of stress, you are going to have a lower or a smaller area under the curve. This is very interesting. If you have people with seasonal affective disorder, if they take their cortisol awakening response in the winter, it will be blunted. However, if you take it in the summer, it will be close to normal. So again, this could be something if you're trying to, let's say I want to test your cortisol awakening response every 6 months, and I do one in December and one in June, and they're affected by SAD essentially. What you might be measuring is not what you're thinking you're measuring. You're measuring really the response of their seasonal affective disorder. So which could be important to understand, but if only if you know that that's what you're measuring. We know that ovulation causes a spike in cortisol awakening response. So if you're repeating this again in a woman who's cycling and you do it at different times of the month, you may find differences, but you may attribute it to the wrong thing. That's something important. You should retest a woman at the same time of the month as you did the last time in her cycle. Interestingly, there's this study that actually looked at suppression of the blunted cortisol awakening response in women with PMS. So again, these are just things that when you start looking in the literature, you start finding all kinds of things that may affect the situation that you're measuring. Now, this was a very interesting study, and again, this shows you the dynamic things that you guys are probably aware of if you're clinicians dealing with lifestyle stressors. So this was 275 police officers in Buffalo, New York, and they provided 4 salivary cortisol samples. Again, this was the classic cortisol awakening response at awakening, 15, 30, and 45, so really the early part of the curve. And they also asked them about their hours of leisure time physical activity based on a 7-day physical activity questionnaire. And they looked at their sleep quality, and essentially what they showed, and this is the group of individuals who generally said that they were either inactive or they were very low active. And you can see that those who had whose sleep quality was good, they had a robust cortisol awakening response. And those who had poor quality sleep, and this is very typical, even one night of poor quality sleep can dampen the cortisol awakening response. But you can see here that there's a big significant difference, almost a really flat curve. However, when they ask these people whether they're good or poor sleepers, but instead those who are very physically active, you'll notice that you can't distinguish the curves. So in this case, there seems to be a moderating role of physical activity. Now it's not perfect. They're not all the way up at the top, but there's a moderating effect. You can see the scales are the same. There's a moderating effect with physical activity in these individuals. And so what does that mean? So you're measuring sleep, you're measuring anticipation of stress, and you're measuring something related to physical activity in these individuals. So you can see the dynamic is multi-layered when we're starting to think about this. So what I'm hoping that I accomplished is to give you an idea that if you're not in the literature and you're not really staying up on things and you're doing a test like this, realize that there's a lot more that you can do and a lot more that you can learn and a lot more ways you can use these tests in your patients. So yeah, cortisol measured correctly and at the right time can be a window into the relationship between various stressors and their metabolic effect. The resilience of a person's stress response, like I showed you with burnout and the high chronic stress individuals. Maybe how acute and chronic stressors, and this is where, again, there's other things that you can do perhaps, but how acute and chronic stressors influence the circadian nature of the HPA-axis. If you're not measuring this in a circadian fashion, you'll never know that. And also potentially what kinds of therapies, for instance, I didn't show this data, but people that had sleep-induced suppression or blunting of their cortisol awakening response, a few months on CPAP, and all of a sudden they have now a robust cortisol awakening response. So getting them to sleep better does demonstrably change that benefit or that biomarker. So I say a summary for now because we've only covered this part of the way, but understand that you're not measuring adrenals. Even though you're measuring cortisol, you're not measuring adrenals, but you're trying, and you're in many cases measuring the HPA-axis and its dynamic function, both the stress-induced alterations and the patient's circadian rhythm. So it's really important to understand that you're using this as a surrogate marker for so much more. Timing is crucial for interpretation. Ensure that this was done right. And when I say timing in the morning or throughout the day, timing in relationship to physical activity, timing in relationship to the month, timing in relationship to the work week, timing in relationship to the year, especially if they have some sort of seasonal affected depressive disorder of some kind. Know the research behind why diurnal measures of cortisol are so important to the functional medicine rather than only to the diagnosis. So if you're only thinking, well, like this endocrinologist that was quoted in this blog, if you're only using cortisol measures and typically a single point serum cortisol level to diagnose, some sort of disease, something I can, put an ICD-10 code on, you're obviously misunderstanding the whole purpose behind the thousands of papers that have been published on the dynamic use of measuring cortisol in a diurnal rhythm for function, and especially in our case, stress-induced function. But there's so much more. The work that Mark and his team have done with looking at urinary metabolites and the publishing that he's done on that, showing that individuals change, the urinary metabolites change based on certain parts of their biology, obesity, other things, insulin sensitivity, and taking that information and kind of rolling it in to what we already know is an extension of what we want laboratories to be doing, taking information that can be asked and interrogating it for more information. I mean, that's why we don't want to stay static in what we're learning. I mentioned provocation or suppression tests. These are things that, again, some of you can definitely use. We typically see provocation when we think of ACTH propagation, but the trier social stress test or other ways. The cortisol awakening response in some ways is trying to use awakening as a provocation. But suppression, dexamethasone is a suppression test, measuring the status quo versus altering parameters. I often get people asking me questions like, well, should they have a lot of light in the room if they don't normally have light in the room when they wake up? And I say to them, well, what do you want to measure? Do you want to measure what happens when they wake up on a normal day? Or do you want to measure the potential of the cortisol awakening response in that individual if they had access to a lot of sunlight when they woke up? And so, that's probably has something to do with what's going on in the seasonal affective disorder individuals. In the winter, they're getting much less sunlight, and so they're getting a lot less stimulus there. So the question is, what do you want to measure? If you want to measure the potential of the HPA axis to dynamically be influenced by light, then you want to probably see what happens when you stimulate them with light and see how robust that response can be. Especially if you have somebody with a flattened curve, you want to say, hey, is there some other reason that's going on? Maybe you wake up and you stay in a dark environment for the first hour, and basically it's saying, look, your body needs sunlight or some sort of light source in order to charge up its day. And then post-therapy changes. What's happening after you give them a therapy for 3 months, 6 months, a year, or whatever, and you want to relook at what's going on in those individuals. So again, there's so much more that you can do with this test. Don't just think about it as some just generic biomarker that puts patients in 3 stages of stress and then you treat them simply. You are really doing sort of like a discovery of their HPA axis dynamic function, and you can go from there and really learn from that. But obviously, like a researcher, you have to be able to understand the data that you're collecting. How is it collected, and what does it really mean, or what could it really mean? And so this is really where I say that the physician is a researcher with the N of 1 right in front of them. And I would say we're just at the beginning. I mean, backing up, we're really just at the beginning of understanding how measuring cortisol helps us understand health. And I didn't even mention DHEA yet. And I'm very interested in understanding how DHEA in combination with measuring cortisol can influence this. So we left that completely off the table, and that's a dynamic part of the discussion that we shouldn't have left off the table in the broader discussion, because DHEA is a major hormone produced in much higher quantities than cortisol, and acts as a counter-regulatory hormone to cortisol in many tissues, and has a very interesting dynamic on its own. So hopefully, maybe we can do a whole webinar someday just on DHEA alone, and then dynamically understand how they work together to regulate the sensitivity of the cortisol response in a whole variety of tissues. If you guys aren't aware that I've written on this topic, this is the 2nd edition of the role of stress in the HPA axis in chronic disease management. And this is obviously written with a clinician in mind who's doing this. So we covered this and of course a whole lot more, and you can get that from our website. So I really appreciate you letting me kind of ramble on about this topic. It's something I think that if you are doing these sorts of tests and you're diagnosing or investigating patients, that you really should know sort of that what sits behind the understanding of why these diurnal tests are so critically important. And hopefully the more N of 1 tests that we have, the larger the pool of data that we have, so that we all can understand better how to deal with stress-induced chronic disease and stress-induced dysfunction. So I appreciate it, and I thank you very much. I thank Mark and Noah and the team there for letting me come on. And if you have any questions, you can either through them or directly to me, you can ask me questions. So I appreciate it. Thank you very much.